Let's continue today to working with reinforcement learning algorithm. So we need to implement environment for trading, and on the previous videos I create this file trading environment.py on the folder tools, but I make some new code there because we're going to use models from scratch, also some reinforced learning model from library what exists right now. I mean from the library step baseline. And for this reason we need to create some schema for this environment. So let's look in what I did. Okay, we need to create a new function with some getInfo, and this getInfo should be call on the receipt function and the issue, and then we can return to object. This one would be numpy an array. It would be what is the next an array, and the second would be our info. Yeah, this is typo. Okay, and what else? Yeah, of course I implement a new ideas about maximum of position, and I did this logic on the step. So it means, yeah, of course, and on the previous library, I mean on the previous version of Gym, they return only 4 objects, but right now it's return 5 objects. It will be observation, it will be our state, rewards, terminate, done, and info. And then I implement some feature to print what is the action, what is the balance, price, etc. Okay, and let's look at how it's working. To test this one, I create a new file. It will be training bot. Let's look in. It is a new file. It is only for demonstration, for example, using Actor-Critic model or DQN. You could use this one. And what we need to do, for example, we create our random data from candlestick, and we implement a feature like what is the initial price, what is minimum volatility, maximum volatility. This is multiplier for volume, and then you create as an environment and do some initialization of your balance. Then you create this model. Then you input how many timestamp we need to analyze to train our bot, and some output for print some blocks. Yeah, of course, if you increase number of total timestamp, the time of persist would be increased. Then we create we need to reset our environment, yeah, like do some initialization, and then when this model would be trained, we can call this environment. Yeah, but I not implement this one, the action. Yep. Yeah, it's incorrect, this part. Okay. Let's do some debug then. So let's decrease number of epochs, and we need to understand what is object return after predict. Let's look at. Take some time to train. Okay, it was very quickly. Let's look in. Okay, this is typo, and we need to take the first argument. It would be an array, and inside in this array we need to take like integer. It would be what is the action, and let's say print this one. Yeah, I print this one, and let's look at what happens. Let's run the full of the code. Train good. Okay, let's look in. So you see we return action 2, sometimes it returns 0, and it will be our price, balance, total worth. Okay, it looks like working, and let's check what does it mean 0, 1, or 2 action. And you need to go to trading environment and looking for on the step function step, yeah. And you see if 0 it means buy, if 1 it would be sell, and another if 2 it should be, yeah, it should be 2. Okay, but this logic we need to create more intelligent, because it is some like an example. I'm create like a schema that you should understand how it's working. Okay, so let's look in this DQN network and looking number of epochs. Okay, if you're going to use Actor-Critic model, and if you input total timestamp, it would be the same, but the time to train would be longer than of DQN. Okay, let's look in, for example, this way, 100,000, I guess. Let's look like this one. It will be more clarified to understand what is an integer. Okay. So you see this is some print from this model. It takes some time, but we need to understand what is the effectivity of this model. Okay. So long. It's only 1000 candlestick. Okay. So we see there's some price and some action, total worth, and you see it's looking something strange because we need to improve our logic, and it would be the main what we should do in the next. And to compare, let's retrain Actor-Critic model, and this one, yeah, I think it should be 1000. But let's look at 1, 1, 1, 1. Okay, sometimes it's 2. Okay. Train board. Oh, sorry, it's incorrect because I not commit object. We redefine this model. I think result will be the same. Okay, let's increase number of time step 10,000. Okay, so this part would be for train. Yeah. This part would be for test, and this one for plot. Okay, we not achieve any results right now. Let's do again, and you see it's some complicated. Yeah, we apply strong model, but we haven't any results right now. We couldn't achieve some positive results. Okay, plot, and you see we couldn't find some dependency. It's very interesting. And to solve this problem, first of all, what we need to do, it is improve our environment. Like I explained on the previous video, we couldn't input all garbage data, and we need to, and also we need to implement more clever approach to achieve rewards. To be honest, there exists too many problems. It's not easy. Like you can think about this one. Like download some data and use some agent from this library, and it's not working. For example, from my experience, I force it's working on train data when I write it from scratch, step by step, to understand all logic. But for on real train, it's another situation. The main problem is you can create this model, and this model would be working, and sometimes it's something broken, and it's not working because the problem of the reward, because we need to create some clever reward function, and another we should train our model only one range of data. I mean, like I explained on the previous video, I mean to train, to trade and train data, for example, on Monday, on morning, for example. Yeah. But of course, there exists the biggest problem of this environment. They create Bellman equation, and there exists 2D matrix, and we're trying to optimize this 2D matrix. But in my new approach, we're working with 3D matrix or 4D matrix. And what happens inside in this Q value table, it's more clever than exists with them. And I think my new approach should be improve results. Let's look in it is in the future. But right now, what we need to do, so we create an environment, we test it, it's working. Then we need to improve some plot charts. Then we need to test this algorithm for cross entropy method. And then we need to what we need to do. We need to working on the environment, because environment it is very important, and the reward function. So guys, see you next time. Bye.